Two identically sized metal spheres on an insulating stand are positioned as shown below. The charge on sphere A is negative 4 times 10 to the negative 6 coulomb, and the charge on sphere B is negative 8 times 10 to the negative 6 coulomb. The two spheres are touched together and then separated. The total number of excess electrons on sphere A after the separation is what? So there's quite a bit going on in this problem, but let's think about what we're looking for and how we can get there. We want to know how many electrons are left on sphere A after they're touched and separated. Well, if we want to know the number of excess electrons, the first thing we're going to have to know is the charge on sphere A after they're touched and separated. So if we take these two conducting spheres and touch them together, what they do is they split the amount of charge equally. In other words, what's the total amount of charge between these two objects? Well, sphere A contributes negative 4 times 10 to the negative 6 coulombs. Sphere B contributes negative 8 times 10 to the negative 6 coulombs. So what's the total amount of charge here? Well, we can just add these two together. And when you add them together, you wind up with 12 times 10 to the negative 6 coulombs. So that's the total charge on both of these combined. And when they touch each other and then separate, they share that amount of charge equally. So if we divide that by 2, we'll know how much charge is on each individual sphere. So at negative 12 times 10 to the negative 6 coulombs divided by 2 gives you negative 6 times 10 to the negative 6 coulombs. So what have we done so far? We've calculated the amount of charge on sphere A after the two are touched and then separated from one another. But we haven't answered the question yet. What we want to know is how many excess electrons this is. So let's take that negative 6 times 10 to the negative 6 coulombs and convert that into electrons or elementary charges. So if we take that 6 times 10 to the negative 6 coulombs, and let's clear up a little bit of space here. Take that 6 times 10 to the negative 6 coulombs and convert it into elementary charges. So we can do that by placing one elementary charge is equal to 1.6 times 10 to the negative 19 coulombs, the value of one elementary charge, which you can look up in your reference tables. Notice that our coulombs cross out. We're going to be left with elementary charges, so we set this up right. And when you do that, you get 3.75 times 10 to the 13 elementary charges, which is the number of excess or extra electrons on sphere A, giving it that charge. And so our answer for this one is going to be answer choice 2, 3.8 times 10 to the 13 extra electrons.